Hello and welcome to the channel ED Technology, and in this series of lecture we are discussing non-homogeneous higher order ordinary differential equation, and our today's topic is shortcut method 1. And in today's video we will have one of the example of shortcut 1 which was the part of previous year GTU paper. So let's go for that example. Here's the example. Solve a differential equation y triple dash minus 3y double dash plus 3y dash minus y equals to 4 e raised to x. This question was a part of our previous year GTU paper. So let's try to solve this third order ordinary differential equation. Now, as we had discussed in our previous two videos, that general solution for the higher order ordinary differential equation will have two parts. One of the part is CF, other part is PI. So we will start with our CF, and for that we will start with decoded form of the given differential equation. So the decoded form of this differential equation will be d cube y minus 3d square y plus 3d minus y, and we are having our forcing function as 4 e raised to x. Now for the auxiliary equation I am taking f of d as a common, 3d square plus 3d minus 1 y is equals to 4 e raised to x. Now for the auxiliary equation, we know the form of auxiliary equation. Auxiliary equation we can label with f of d equals to 0, and right now I am having f of d as d cube minus 3d square plus 3d minus 1. Let me get this equals to 0, and we need to factorize this cubic equation. This is a cubic equation in terms of d, so we will have three values of d which is gonna satisfy this cubic equation. Now this is, I'm not going deep in the factorization. This is as simple as that. The factors of this will be d minus 1, d minus 1 and d minus 1, because this is nothing but the expansion of d minus 1 the cube. So the factors are d minus 1, d minus 1, d minus 1. Using this we will have the roots will as 1, 1 and 1. Now observe, I am having three real roots for the auxiliary equation f of d equals to 0, and observe here the roots are repeated. Roots are real and repeated. If roots are real and repeated, then we know the way how to write CF. Our CF will be, I'm having three repeated roots, so I will be in need of a polynomial with three steps. So this will be C1 plus C2x plus C3 x square, and my root is 1, so it will be e raised to 1x, that means e raised to x. So this will act as my CF for this particular part, for this particular differential equation. Now let's move for the PI. For the PI, for the second part of this, we know that the formula for the PI is 1 upon f of d into r of x. So let me denote that 1 upon f of d into forcing function r of x. Right now my forcing function is 4 e raised to x, and my f of d is d cube minus 3d square plus 3d minus 1, and my forcing function is 4 e raised to x. Now as per our shortcut method 1, we need to compare this particular with e raised to x. E raised to x, if we're gonna compare that with e raised to x, then I will have value of a as a 1. Now I'm having value of a as a 1. Now if, as per our method, if I'm gonna replace d with 1, then surely the denominator will become 0. Why? Because I'm having 1 as a root of that auxiliary equation f of d equals to 0. To bypass that confusion, what was a shortcut for that? We need to differentiate, we need to modify our 1 upon f of d. And what was the way how we were modifying our 1 upon f of d? We were multiplying numerator with x, and we are we were differentiating denominator with respect to capital D. So let's proceed with the same. What I'm doing, I'm multiplying denominator with x, and then I will differentiate the denominator with capital D. So multiplying denominator with x, so 1 into x gives me x. I'm differentiating this whole term with respect to d, then it will give me the derivative of d cube will 3d square. The derivative of 3d square give me 6d. The differentiation of 3d will be 3 and differentiation of 1 will be 0. And my forcing function will be as it is, 4 e raised to x. Now what we need to do in the next step, once again we will try to eliminate d with a. Now right now my a is 1. If I'm gonna replace d with 1, then it will be 3 ones are 3 minus 6 plus 3. Once again it will give me 0. So what to do if the problem is not solved yet? The problem was that by replacing d with a, my denominator was becoming 0. I had modified that term with our shortcut, yet the problem is unsolved. Then what to do? We need to remodify it as we had done previous. So once again I will modify this term. I will multiply numerator with x. So I was having x, once again multiplying x with x will give me x square. I will differentiate the denominator with respect to capital D. So this will gives me 6d minus 6d, derivative of 60 will be 6 and derivative of 3 will be 0. And my forcing function will be as it is, 4 e raised to x. Now after remodifying it, once again we will try our shortcut method. I will gonna replace d with 1 once again. So if I replace d with 1, then it will be 6 ones are 6 minus 6, yet problem is not solved because my denominator is becoming 0. So what I will do, I will repeat the same step once again. I will multiply numerator with x. So earlier I was having x, now it will be x cubed. I will differentiate the denominator with respect to capital D. 6d will give me 6 and that 6 will gives me 0 because derivative of constant is 0. And my forcing function will act as it is, 4 e raised to x. Now observe, in this particular term I'm not having capital D. So we're done. This is nothing but this is a yp for the given differential equation. So if my yp 1 upon f of d r of x is free from capital D, then we are done with that. So for the general solution of this differential equation, I will have y equals to yc plus yp, and I was having yc as c1 plus c2x plus c3x square e raised to x, and my yp is x cube by 6 4 e raised to x. So this is the general solution for this differential equation. This is a question from previous year GTU. So hopefully this will help you guys. Thank you very much.